A power plant just switched on in the mountains of China, and it runs on something every factory on Earth spends millions of dollars trying to throw away. Not coal, not gas, not sunlight. It runs on the one gas we blame for warming the whole planet. And somehow, it makes more electricity than the machines we have used for 200 years. That is not a typo. This new plant is already beating the old technology by 50%. 50% more power from the exact same amount of heat. No new fuel burned, no new pollution made. Just a smarter way of doing something we have done the same way since the age of steam trains. So how do you turn the thing we are trying to get rid of into the thing that powers our homes? Stick around, because the answer involves a state of matter you have probably never heard of, a 60-year-old idea that everyone gave up on, and a plan that could one day power spaceships. The machine that never changed here is something wild to think about. Almost every single power plant on Earth works the exact same way. It does not matter if you are burning coal, splitting atoms inside a nuclear reactor, or using mirrors to focus sunlight. The end result is always the same. You use heat to boil water. The water turns into steam. That steam blasts through a machine called a turbine and spins it like a pinwheel in a hurricane. The spinning turbine makes electricity. This idea is old. Really old. It is basically the same trick that powered steam trains and factories 200 years ago, back before anyone had even invented the light bulb. Cars have changed. Phones have changed. Computers have changed so much they barely look the same from one decade to the next. But the heart of a power plant has stayed frozen in time. Boil water, make steam, spin the turbine, repeat. Engineers have tried to improve almost everything around that process. Better fuels, better materials, bigger turbines. But the one thing nobody could change was the steam itself. Until now. A team in China just built something that skips the steam completely. And it turns out the water was the weak link the whole time. If you are the kind of person who likes learning why the world works the way it does, this channel breaks down stories like this every single week. The real story, not the hype. Hitting subscribe means you will not miss the next one, and there is a lot more coming. The ingredient. Nobody wanted. Now here is where most videos about this topic get it completely wrong, so let's clear it up fast. This is not some magic device that sucks pollution out of the sky and cleans the planet while making electricity. That is not what is happening here. This plant does not pull carbon dioxide from the air, and it does not burn carbon dioxide as fuel either. You cannot burn it. It has already been burned. That is exactly why it is carbon dioxide in the first place. So what is really going on? Think of it this way. Every power plant needs some kind of messenger to carry heat from the fire to the turbine. For 200 years, that messenger has always been water, turned into steam. What this new Chinese plant did was swap out the messenger. Instead of water, it uses carbon dioxide, sealed up tight in a loop, used over and over again forever. It never escapes into the air. It never runs out. It just keeps carrying heat back and forth, again and again, like a delivery truck that never stops driving the same route. Why would anyone bother swapping the messenger? Because it turns out carbon dioxide, when you treat it the right way, might be one of the best heat messengers ever discovered. And the reason why involves a trick of physics that sounds almost made up. To understand why, we need to talk about what happens when you squeeze carbon dioxide really, really hard. The in-between state. You already know the normal forms that matter can take: solid, liquid, and gas, ice, water, and steam. Carbon dioxide can be all three of those too. Frozen, it becomes dry ice, the stuff that makes spooky fog at concerts. As a gas, it is the invisible air you breathe out right now. But there is a fourth option, a strange in-between state, and it is the secret to this entire story. If you take carbon dioxide and crush it under massive pressure while also heating it up past a certain point, something bizarre happens. It stops being clearly a gas, but it also refuses to become a normal liquid. It gets stuck in a weird middle zone. Scientists call this the supercritical state, but you do not need to remember that word. Just picture it like this. It flows and spreads out like a gas, filling every corner of its container. But it is also thick and packed tight, carrying heat the way a liquid does. It is basically getting the superpowers of two different states of matter at the exact same time. That mixed superpower turns out to be huge for a power plant. A regular gas is easy to push around, but terrible at holding heat, like trying to carry warmth in a balloon. A liquid holds heat wonderfully, but is heavy and hard to move, like carrying warmth in a bucket of wet sand. This strange in-between form of carbon dioxide does both jobs at once. It moves easily like a gas, but it grips onto heat like a liquid. That combination gives engineers three huge wins. First, it moves heat around so well that almost none of it gets wasted along the way to the turbine. Second, this charged-up carbon dioxide is so dense and powerful that the turbine spinning it can be tiny compared to a normal steam turbine, small enough that you could practically wrap your arms around a machine that does the job of something the size of a school bus. Third, turning carbon dioxide into this state takes far less energy than boiling water into steam, so the plant saves energy before it even starts making electricity. Put all three of those together, and you get a power system that squeezes more electricity out of heat that used to just disappear into thin air. This sounds like the kind of idea that should have been used decades ago. So why is it brand new? The 60-year wait here is the twist. This idea is not new at all. Scientists in Italy and the United States were already exploring this exact concept back in the 1960s. The math worked out perfectly on paper. Everyone agreed it should be better than steam. And then the whole idea sat on a shelf, untouched, for 60 years. Why? Because building it turned out to be a nightmare. To make this system work, you have to keep carbon dioxide under extreme pressure and extreme heat nonstop for years at a time while it rushes through pipes and machines. The materials available back then simply could not handle it. Metal corroded, seals cracked, parts wore down under the constant pressure. The very thing that made this fluid so powerful also made it brutal on the equipment trying to contain it. So, for 60 years, this stayed a brilliant idea that nobody could actually build. That changed when a team from China's Nuclear Power Institute decided to solve the materials problem instead of walking away from it, the same way they have cracked other tough engineering puzzles before. They spent years working on stronger metals and better designs until the technology could finally survive the pressure it was built to handle. The result is a project called CO₂, sometimes called Super Carbon No. 1, built right inside a working steel factory in the mountains of Guizhou province in southwest China. And the location is not random at all. Steel factories produce insane amounts of heat, and most of it just floats away into the sky doing absolutely nothing. This new plant grabs that wasted heat before it escapes and turns it directly into electricity. The first section of the plant, a 15-megawatt unit, connected to the power grid in December of last year and ran steadily for months. Then, this past May, engineers switched on a second matching unit, bringing the whole project up to 30 megawatts of power, all generated from heat that used to just vanish. China's Nuclear Power Institute called it the world's first full-sized commercial demonstration of this technology, and the biggest one ever built. And that 50% efficiency number is not just a rumor. Compared to old-fashioned steam systems doing the exact same job, this new plant is squeezing out roughly 50% more electricity from the same wasted heat using smaller equipment to do it. That alone would be a big deal. But the real reason a nuclear energy company built this thing has almost nothing to do with steel factories at all. Bigger than one factory. Here is the part that should really make you sit up. The steel factory is just the testing ground. The real target is something much bigger. Today, nuclear power plants make electricity the exact same old-fashioned way, by boiling water into steam. If engineers swap that steam system for this new carbon dioxide system instead, A nuclear plant could shrink down dramatically while producing even more power. Picture the massive turbine buildings you see in photos of nuclear plants. This technology could shrink those down to a fraction of the size. And it does not stop with nuclear power. Engineers behind this project have already pointed towards small mobile power generators that could be shipped anywhere in the world and set up fast. They have pointed towards solar power plants that use mirrors to focus sunlight into heat. And most surprising of all, they have pointed toward outer space, where every single pound of equipment on a spacecraft is incredibly expensive, and a tiny, powerful turbine like this one could be worth more than gold. Nobody is saying this replaces every power plant on the planet tomorrow. 30 megawatts is small compared to how much electricity the world uses every single day. The big questions now are whether this equipment can survive not just months, but decades of constant use, and whether it can be built cheaply enough to spread everywhere. Those are fair questions, and only time will answer them. But here is the bigger truth hiding underneath all of this. Almost every bit of electricity powering the device you are watching this on right now came from a spinning turbine, and almost all of those turbines are spun by steam. We built our entire modern world on top of a 200-year-old idea that most people assumed could never really change. This new plant is proof that it can. If a factory tucked away in the mountains of China can rewrite 2 centuries of power plant history using nothing but carbon dioxide and some very stubborn engineers, it makes you wonder what other old rules of energy are just waiting for someone to break them. If you liked learning how this works, smash that like button, hit subscribe, and turn on notifications so you catch the next deep dive the moment it drops. Do you think this technology eventually replaces steam power everywhere, or is steam just too deeply built into the world to ever fully disappear? Drop your answer in the comments. I really want to know where you land on this one. And if you want to see more stories like this, check the videos linked right after this one.